Hey geometry class. In this lesson, we're going to be looking at section 1.5 and we're going to be using inequalities in one triangle. Well, this one is about inequalities in just one single triangle. The next section is we're going to be looking at inequalities in two triangles. So let's just go ahead and get started. We're going to start out with some theorems. Okay. So the position of the longest and the shortest sides of a triangle are related to the positions of the longest and the smallest, or the largest and the smallest angles in a triangle. So let's look at this first theorem. It says if two sides of a triangle are not congruent, then the larger angle is opposite of the larger side. So let's look at this right here. If we know that let's see, side AB is bigger than, or yeah, longer than side BC, then we should know that the angles opposite, let me draw these in. So the angles opposite of each of these sides, meaning this side right here, here's the opposite angle. This side here, there's the opposite angle. Now, if AB is bigger than BC, then angle C is going to be bigger than angle A because it goes along with the sides right here, the opposite sides and opposite angles. Okay, so let's look at this next one. If two angles of a triangle are not congruent, then the longer side is opposite of the larger angle. So same thing going on here, except now we're looking at the angles. So if we know that angle Z is the larger angle, then the side opposite of that angle is going to be the longest side. So in this conclusion right here, if angle Z is bigger than angle Y, then side XY is larger or longer than XZ. Okay, so let's look at some exercises. Okay, in this one it says write the angles in order from smallest to largest. So going from what we just looked at, we're going to number these in order first. Here is the shortest side. I'm going to call that 1. The next to the shortest side, 2. And then here's the longest side. Okay, so the angles opposite of each of these all right, is how we're going to number them. Angle F is going to be the smallest. Angle H is going to be in the middle. And then angle G is going to be the largest. So name it just like that. In order. Angle F, smallest. Angle H, the next one. And then angle G. And there we go. It's in order from largest or smallest to largest. Okay, now let's do it again. Name these angles from largest to smallest. Okay, so I'm just drawing the lines of the things that are the angles that are opposite of these sides. Okay, so I'm going to number them. Angle B goes with 9 here, which is the smallest side. So that's 1. Angle A is the next smallest one. Remember that, 2. And angle C is going to be the largest because it goes along with the largest side. Okay, so name them in order. Angle B, angle A, and angle C. And we're done. Okay, now we're going to do just what we've been doing, but in reverse. Now we're asked to write the sides in order from shortest to longest. For this one, first we need to figure out what is this angle R right here. And you should know that all angles inside a triangle add up to 180. So subtract 72 and 60 from 180. This last angle right here is going to be equal to 48 degrees. Okay, so now naming the sides from shortest to longest, I'm going to say it like this. Here's the opposite side of 48 degrees. That's going to be the shortest. The next to the smallest angle is 60. The opposite side of 60 is going to be the next to the shortest. And then the largest angle, 72, its opposite side is going to be the longest. So name your segments. Whoops, sorry guys. All right, so name those in order from shortest to longest. First is PQ. Next is, let's see, QR. And then last is PR. And we're done. All right, this next example, just like the last one, do this one again. We need to figure out what angle E is equal to. This is 90 degrees and D is 22 degrees. So subtract those two angles from 180, we get the angle measurement of 68 degrees. Okay. All right. So let's number these sides from shortest to longest. So angle D here is the smallest angle. Sorry again. All right. Angle D is the smallest angle, so the side opposite, EF, is going to be your shortest side. So EF is our first one. The next one is going to be 68 because this is 90 degrees right here. And its opposite side is DF. And then the longest side is this last one, the one opposite of the 90-degree angle, which is DE. And we're done. Okay, now a triangle is formed by 3 segments, but not every set of 3 segments can form a triangle, just like you see in this example here. We have segments with lengths 7, 4, and 4. That can form a triangle, but segments with lengths 7, 3, and 3 cannot form a triangle because it falls short of becoming a triangle. So here we have a relationship that is formed when we are looking at segments of triangles, called the triangle inequality theorem. The sum of any 2 side lengths of a triangle is greater than the third side length. So looking at this triangle ABC, this right here is always true. All three of these inequalities. So any two sides, like AB, BC, added together, must be greater than AC. And then same thing goes with BC and AC. Add those two sides, it's going to be greater than AB. And then lastly is AC and AB. Add those two sides, it must be greater than BC. And notice it says greater than and not equal to. Never equal to, just always greater than. Okay, so let's use that triangle inequality theorem to answer this. It says tell whether a triangle can have sides with the given lengths, 7, 10, and 19. And explain. I'm not going to necessarily ask you to explain. I want you to show your work. And this is how you're going to show your work on these types of problems. So here's the three sides of your supposed triangle. And we're going to just try to find out if these are sides of a triangle. Can these sides form one? By using the inequality theorem. We're going to take our first two, add them together. They must be greater than 19. And the next two, 10 and 19, must be greater than the other side, 7. And 7 and 19 must be greater than the third side. Well, these two statements are true, but this statement right here is false. That when you add that together, you get 17, and 17 is not greater than 19. So these three segments right here cannot be a triangle. Okay? All right, in this exercise here, we're asked to do the same thing as the last one. Tell whether the triangle can have sides with given lengths and explain. Explain by showing that inequality theorem. So here are the three sides. Let's write them all out. So say 2.3 plus 3.1. It needs to be greater than the third side. And let's say 2.3 plus 4.6 must be greater than 3.1. And then 3.1 plus 4.6 must be greater than 2.3. If you do all of this addition, you will see that this is true, that's true, and that is true. So we can conclude that these three segments can be a triangle. All right, this exercise right here is just like the last two that we did. The only difference is we are asked about these three segments when n is equal to 4. So what this means is we just have a little bit more algebra to do. We need to plug in a 4 for all of our n values. And when we do that, we get 10 here. N squared minus 1, that gives us, let's see, whoops. We get n squared, that's 16 minus 1, that's 15. And then 3n, that gives us 12. All right, so let's do all of the inequalities. So we're going to get 10 plus 15 must be greater than 12. 10 plus 12 must be greater than 15. And 12 plus 15 must be greater than 10. all three of these inequalities are true. So we can conclude that these three segments can be a triangle. So another thing we can do with the triangle inequality theorem is answer a problem like this. It says the lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possible lengths for the third side. So we're going to be using the triangle inequality like this right here. I'll show you a shortcut to this here in just a second, but let's do it the long way first. So we have side lengths 22, 17, and an unknown. We'll call it x. Let's do the triangle inequality theorem with these three. Okay, so 22 plus 17 must be greater than x. I'm going to come over here and say 17 plus x must be greater than 22, and 22 plus x is greater than 17. Okay, solve all of these inequalities. So on this one, we're going to get 39 is greater than x. This one, we're going to subtract 17 from both sides of that inequality symbol. Just treat it like an equal sign. And you get x is greater than 5. And on this one, we get x is greater than negative 5. Well, since x cannot be a negative length, we're going to ignore this one right here. And our answer is going to come from these two inequalities here. And how you're going to come up with the range of possible lengths for that third side. Your third side is x, remember? So the range goes from the smallest to the largest number. So 5, oops. And you're going to write it like this. X is between 5 and 39. That's how that inequality reads right there. There's your solution. X is between 5 and 39. Now, I said it's going to show a shortcut to figuring out what that range of possible lengths of the third side could be. Notice 5 you can get from subtracting the two numbers that you are given. And then 39 you can get from adding the two numbers. So your inequality is going to be between the smallest number and the largest number. And this is how you're going to write it, just like this right here. 5 is less than x, and x is less than 39. Okay, so let's do the next problem just like that. Okay, it says, so this is just kind of a word problem here, but it's just like the last example. It says the figure shown, shows the approximate distances between cities in California. What is the range of distances from San Francisco to Oakland? So from San Jose to San Francisco and San Jose to Oakland, we know the distances. One's 51 miles and the other one's 46. So we're wondering, what are the range of possibilities for the distances between San Francisco and Oakland? Now, remember, like I did the last time, this range is going to be between these numbers right here. We're going to subtract these numbers, and then we're going to add them together to get the range. So the smallest one is going to be 51 minus 46. And the largest amount is going to be 51 plus 46. Okay, so this one is going to end up being 5. And this one 97. And there is our solution. All right, so the last thing I want y'all to do is this lesson quiz all on your own, and we will go over it in class when I see you next. So this is the end of it. I'll see you all when I see you. Goodbye, everybody.